All right, quick help with WebAssign. This is question 8. This one actually is really focused on knowing your vocabulary. I haven't done formal notes with you guys, at least where I've written down every single definition. So this is where I want you to kind of reference your textbook, be resourceful. The PowerPoints will have information like this as well. All right, so we're basically given kind of a dot diagram almost. It shows, of course, that they start, the red being the object, they start at a position of 2 meters. I know that because it's labeled X for position in meters. And then they move to 10 meters. They then actually go backwards from 10 to 8, and then they finish off from 8 to 11. All right, looks like it kind of keeps going, but that's actually stopping at 11. Distance is a vocabulary term that you will not often hear me use because distance actually doesn't account for direction. All right, we call this a scalar. We'll learn about this in the future, but the definition of distance, real simple, it's the total length traveled. All right. So it doesn't care about direction. So think of it like this. If you're walking around, every big step, if you do big steps, every big step you take is 1 meter. And it doesn't matter if you do it to the left or the right because it just cares about the total amount of steps you take. So if you think about this then, they go from 2 to 10, which is 8 meters. The difference between them, of course, and you could count from here. You could go to 3 as 1, 2, 3, 4, 5, 6, 7, 8. When they then walk backwards, I don't care about the direction. I just keep counting the steps. So I was at 8, and then when I walk backwards, it would be 9, 10, because I'm just counting up the total amount of meters that they go, which would be like the big steps. And then from 10, I would go then again, counting them out, 11, 12, 13. So total length is just count out how many meters they went, disregarding negative and positive directions. Again, 2 to 10 is 8. 10 to 8 is another 2, so add that, which makes it a total of 10. 8 to 11 is then another 3, which add that to 10. That's now 13 meters. Okay? Ours are all the same for question 8, so that's actually the answer for the total distance that they traveled. Displacement's different though. Displacement is the term I've been using. It's kind of similar to distance, but it actually cares about direction. So the definition of displacement is actually the change in position. You could write this in the form of an equation that would basically say, hey, it's the change in position, delta, the Greek letter delta means change, and x means position. And if you think of math, change mathematically is a final minus an initial. So we do actually care about the positive direction and the negative direction in between. That's why we like displacement, because it will tell us, are you going in the positive or negative direction and what happened in between. If you want to simplify this, all you need to do is figure out, okay, the initial position was at 2 meters, and then right here, the final position is at 11 meters. If you plug in those values, 11 meters, and subtract it from the initial 2 meters, that change actually tells you the total displacement. All right, so 11 meters minus 2 meters would be 9 meters, and that would represent your total displacement. All right, hope that helps.